Number 1 says to qualify for a loan from a bank, the total in someone's checking and savings account together must be $500 or more. Which of these inequalities best represents the situation? So one thing you want to decide is if your total should be higher than 500 or lower. And this says more, so 500 or more. So this means we want bigger than 500. It also, you want to decide if it can be equal to 500 or not. So this one says $500 we could have, or we can have more. So that means it can be equal to 500 or it can be higher. So when we look, we don't want these ones that don't have the equal sign under them, because those mean we can't just have 500, and we actually can. So then you want x plus y to be greater than 500. And this one is less than, since the little part is by these two. Okay, and x plus y, the opening or the larger part of our inequality, is with x plus y. So x plus y is greater than 500. So we would want this last one. Then it says, complete the graph so that it represents the solutions to an inequality representing the situation. So they've graphed for us x plus y equals 500. And so we just have to decide where we want to shade, because we want it to be greater than or equal to 500. So we're good with this solid line. So I'm actually just going to draw over it just to reiterate that we want this to be a solid line. So we're good with that. And then you can plug in a number like you've been doing before to see which region you want to shade. So if I just plug in the point 100, 100, and really it's just saying add these two numbers together, right? So this equation just says add those two numbers together. And 100 plus 100 is 200, which is less than 500. So that's not enough. So we can have anything above this line in our bank account. So any of these would be good. And again, you can just pick one to kind of check. So if I did this point here, okay, this point here is the point 500, 300. And if I add those together, that's 800. So then 800 is more than 500. And then it said, be clear whether you want a solid or dashed. And like we said, we want solid. Number 2, the soccer team is selling bags of popcorn for $3 each and cups of lemonade for $2 each. To make a profit, they must collect a total of more than $120. Write an inequality to represent the number of bags of popcorn and the cups of lemonade sold in order to make a profit. So more than doesn't say 120 or more. So this has to just be greater. Okay, it can't be equal to 120. Okay, so not equal to 120, but it has to be higher than 120. So we're doing $3 for popcorn, which we're calling P. So $3 times the number of popcorns we sell, plus $2 times the cups of lemonade needs to be greater than $120 for us to make a profit. Now it wants us to graph this solution set. And so I'm just actually going to take and do the intercepts of each of these. And so if we take a look at this equation and we look at the equal sign one, right? So if we look at the equal, the equation, that'll help us get some different intercepts. So when we are only selling popcorn, so if we only sell popcorn to make $120, so we'll divide by 3 here, we get that the popcorn we would need to sell 40 to equal 120. So if we were over here at 40 popcorns, we would make $120. Then we want to look at how many cups of lemonade would we need in order to get to the 120. So you can just divide these by 2. And so we would have to sell 60 cups of lemonade if we only sold lemonade, right? So 0 popcorns, 60 lemonades, or 40 popcorns with 0 lemonades. This gets us the line that we're going to connect. Now, remember that this line is just greater than, not equal to. So this means that we're going to have a dotted line. So when you connect those, okay, if you like lay a ruler or you just do it freehand, remember that you're going to want a dotted line. So we're just going to connect. Whoops, thought I had the line. Let me grab this. Okay, so you're just going to connect with a dotted line there. Then we need to decide where the boundary needs to be for this. Okay, so again, you can just plug in a number. So if I plug in this number right here, or this point, which is the point 10, 20, we can figure it out. So that's 10 popcorns, 20 lemonades. Okay, so if I take this equation and I plug in that point, we will see if it's greater than 120 or not. If it is, then it's in our boundary. If it's not, then it's not in our boundary. So popcorn, so 3 times 10, and then lemonade is 2 times the lemonades. So we get 30 plus 40, which is 70, and 70 is not greater than 120. So this is false. So that point is not in our solution. So that means that the other side of the boundary line is our solution set. So up here, and again, you can plug in a point up here just to convince yourself. And then for this last one, how could we check if the boundary is included or excluded? Just pick a point that's on it. I would pick the intercept that you just found. Okay, so when you did the intercept, if you plug in 60, okay, so for this one, we're going to plug in the point 060. So we would have 0 popcorns and we have 60 lemonades. Okay, is that greater than 120? Well, it's equal to 120, right? So 120 is not greater than 120. So false. So the boundary line is excluded. That's why we did that dotted line. Number 3, tickets to the aquarium are $11 for adults and $6 for children. An after-school program has a budget of $200 for the trip. Now, if their budget is $200, that means they can spend $200. Okay, so they can spend $200, so they can have equal to $200 for this. Okay, or they can spend less than. Okay, so they can spend equal to or less than the 200, right? So if they spend just 150, that's fine. But what they can't do is spend more than 200. So when we're looking at this equal to means that we're looking for a solid line. So we want solid since 200 is part of it. So we can rule out A and D right away. Then we want the total of 11x, and I'm just going to leave a blank, plus 6y. Whoops, I'm going to leave a blank for the y also. To be less than or equal to 200. So now when you pick a point, okay, and we can even pick 0, 0, okay, which is really easy to plug in because when you do 0, 0, okay, that's 0 plus 0. Is that less than or equal to 200? So is 0 less than 200? Yes, so it's part of the boundary. But it doesn't really make as much sense because then you're not bringing anybody to the aquarium. So let's pick a different number. So if we did this one, okay, which is 4 adults and 16 children. Okay, so we're going to do 4 adult tickets at $11 a piece, and we're going to do 16 children's tickets at $6 a piece. So 6 times 16. So this is going to be 44 for the adult tickets and 96 for the children's tickets. And then 96 plus 44 is 140. Is this less than or equal to 200? And that's true. So this point is in our solution set, meaning it should be shaded. Okay, so C would be the correct answer there. Anything in this one above the line is too much, okay, because all of this stuff is over the 200. Number 4, Tyler filled a small jar with quarters and dimes and donated it to his school's charity club. The club member receiving the jar asked, "Do you happen to know how much is in the jar?" Tyler said, "I know it's at least $8.50, but I don't know the exact amount." So write an inequality to represent the relationship between the number of dimes and quarters. So we know that dimes are worth 10 cents, okay? So we'll put 10 cents times the number of dimes. And then we know that quarters are 25 cents. So we'll do 25 cents times the quarters. Now that needs to be at least $8.50. And at least $8.50 means it's greater than or equal to $8.50. So we know it could equal exactly the $8.50, or it could be more than that. Now they want us to graph this and explain what the solution means. So again, I'm going to look at doing the intercepts here. So if I just look at this as an equation, so if I just put an equal sign here and I look at just dimes. So if I had just dimes in this situation, so if I had $8.50 in dimes, so $8.50 divided, so we divide by 0.1 or 0.1. And we would find out that if they were all dimes, we would need 85 of them. Okay, so if we had all dimes, we would need 85. Then if we had all quarters, so if there were only quarters in here to equal out to $8.50, so we'll divide by 0.25 and find out that we would need 34 quarters to get to $8.50. So 34 quarters would be about here, so 0.34. And so in this case, remember that it could equal, so it could equal $8.50 because he said at least. So either we have $8.50 or we have more. So we want a solid line connecting these 2 points, because that boundary would be all of the parts where we have $8.50. And then, you know, we've done a couple of these. So above $8.50 would be the at least. So up here would be he has more than $8.50 if he's in any of this shaded region. And the boundary line, okay, on the line is exactly $8.50. So that's equal to $8.50. And then everything above the line is higher than $8.50. Suppose Tyler knew there were 25 dimes in his jar. Write an inequality that represents how many quarters could be in the jar. So we'll just take and figure out the amount of money he has in dimes. So we'll plug dimes in. And then we want to figure out how much we have left of the $8.50. So 10 cents times 25 dimes means we have $2.50 in dimes. And then we're looking for how much our quarters would need to be then. So we can just take that $2.50 out of our total. So basically subtracting $2.50 from both sides. And we find out that our number of quarters needs to be greater than or equal to $6. And so then we'll just divide by 25 cents to figure out how many quarters that is. So if we take $6 divided by 25 cents, we find out that the number of quarters that we need is more than or equal to 24. So we need at least 24 quarters if we have 25 dimes. So if we have 25 dimes, we need at least 24 quarters to be at $8.50 or higher. Number 5, Andre is solving this inequality. He first solves the related equation. This seems strange to Andre. He thinks he probably made a mistake. What was his mistake? So it seems fine here, right? He subtracts 3 from both sides. So then you get 0 and you get 0. So you're left with the 14x equals 8x. But then he goes and divides by x because he loses those x's. And you don't want to divide by a variable because then you lose those solutions. And so that's his mistake. We don't want to divide by a variable. Okay, so he divided by x. And what he should have done is subtracted 8x to get those x terms together. Okay, so to bring them together. So 14x minus 8x is 6x equals 0. Then divide by 6 to find out that x equals 0 is a solution to this equation. Number 6, Kieran says, I bought 2.5 pounds of red and yellow lentils. They were both $1.80 a pound. I spent $4.05. Write a system of equations to describe the relationship between the quantities in Kieran's statement. Be sure to specify your variables. So I'm just, to make it easy, I'm going to do R is the red lentils, okay, or the pounds of red lentils, right? And then yellow, or Y, will be the pounds of yellow lentils. So LBS being pounds. So this is going to be R plus Y equals 2.5 because he bought a total of 2.5 pounds. And then each of those costs $1.80. So $1.80 R plus $1.80 Y equals $4.05. Then Elena says, well, that can't be right. Explain how Elena can tell that something is wrong with Kieran's statement. So the fact that both of these lentils are the same amount of money, we actually know that he bought 2.5 pounds of things that cost $1.80, right? So if you do 2.5 times 1.8, that gives us a total of $4.50. So since we know the cost of both is the same, we know how much this cost him, and it was $4.50. So this cannot be possible here. So then Kieran says, oops, I guess I meant to say that I bought 2.25 pounds of lentils instead. So let's revise his equation. Or his system, right? So, R. So R plus Y is actually 225, and then 180 R plus 180 Y is equal to, is equal to 405 because his price stayed the same, right? So his weight changed. He only bought 2.25 pounds instead of 2.5. So part D asks us, is it possible to tell for sure how many pounds of each kind of lentil Kieran might have bought? Explain your reasoning. And no, it's not, because these are actually equivalent equations. So if I just divide by 1.8 to both sides here, I would get R plus Y equals 225. So that means that these two equations are equivalent. So they are going to graph right on top of each other. So if we were to graph this line, okay, let's say that this is the first one. When we graph this second one, it's going to be right on top of it. So everything that's a solution to this top one, okay, everything that's a solution here is also going to be a solution here. And that's because they cost the same amount. So if he got 1 pound here and he got 1.25 here, it's going to equal out in both equations. If he got 2 pounds of the red and he got 0.25 pounds of the yellow, it's going to work out in both equations. So no way to actually find out there. All right, in number 7, they give us an inequality here, and then they ask us to select all values of x that are solutions. You can absolutely take these 6 values and plug them in, and then you want this left side to be less than the right side. So not equal to it, but this, when you plug into this side, it has to be smaller than the other side. So you can do that, and it will work. To me, that seems like it's going to take me a really long time to have to plug in 6 different values. So instead, I'm going to decide to solve the equation using algebra so that I can figure out the boundary point. And to me, that feels like a better use of my time. You can do it how you want. So if you want to plug all those in, you certainly can. So I'm going to distribute this negative in here. So negative 3x or minus the 3x, and I'm going to subtract the 2. And then this is less than, distribute this negative 8. And really, I'm going to change this to an equal sign because I'm just going to solve for the boundary here. So negative 8 times x is negative 8x. Negative 8 times 1 is negative 8. Then I'm going to combine these like terms here. So I've got the negative 3x. Negative 7 plus negative 2 is negative 9. And then that equals that other side of negative 8x minus 8. So then I'm going to start getting like terms together. So I want this negative 9 and this negative 8 together. But I have to get the negative 9 off of this side or zero it out. So I'm going to have to add 9 to both sides because then this becomes 0. So I'm left with just negative 3x equals negative 8x, and then negative 8 plus 9 is positive 1. Then I want to get those x terms together, so I'm going to bring this 8x over. So negative 8x, I need to add 8x to both sides. So negative 3x plus 8x is 5x. Negative 8x plus 8x is 0, so I'm left with 1. Then we can divide by 5 here. And we get that our boundary point is 0.2. So now what that did for me is now I know, okay, that 0.2 will equal both sides out. And we don't want both sides to be equal. Okay, we want the right side to be less than. So I don't even have to plug this in because I know that they will equal. So now all I have to do is plug in one of these because here's 0.2 on your number line. And we know that's not part of the boundary, but it's either above or below this. So now you just plug in either 0.1 or 0.3 and you'll find out the boundary. So I'm just going to plug in 0.3 and find out if that is a solution or not a solution. So when I go back up into this original equation, right? So we're going to do negative 7 minus 0.3 plus 2. And then see if that is less than negative 8 times 0.3 plus 1. I'll just move this stuff out of here. All right, let me fix this. All right, so then you just can type this in your calculator, right? So 0.3, you're doing negative 7 minus, and then 0.3 plus 2 is 2.3. So you're subtracting 2.3. So negative 7 minus 2.3 gives us negative 9.3 for this side. And then we're just going to see if that's less than this other side. So then 0.3 plus 1 is 1.3. So we have negative 8 times 1.3. And negative 8 times 1.3 is negative 10.4. So is negative 9.3 less than negative 10.4? No, because here's negative 9.3, negative 10.4 is over here. So negative 9.3 is actually bigger than. So then this is a false statement. Okay, the left is not smaller than the right. So 0.3 is not in the solution zone. So this other part is in the solution zone. So 0.3, not a solution. that means all of these are solutions. So again, you could go ahead and plug all 6 of these in to find out, or you can solve the equation to figure out your boundary and then just plug in 1. Number 8, here's a graph of the equation 6x plus 2y equals -8. Are these 2 points solutions to the equation? Explain how you know. So if we look at where here's 1.5 on the x, -4 in the y is right here. Not a solution because it's not on the line. 0, -4. So 0, -4 is right here. This one is on the line, so it's a solution. Now, part B wants us to check if each of these points is a solution to this inequality. So you can certainly plug these all in. I'm going to start at 0, 0. So I'm going to plug in 0, 0 so that I can figure out the shading zone. Okay, so I'm going to plug in 0, 0 and see if it's a solution. So we're going to go 6 times 0 plus 2 times 0, is that less than or equal to -8? So is 0 less than or equal to -8? And that's false. 0 is bigger than -8. So 0, 0 is not part of my solution set. So that means the other portion of the boundary is my solution set. And what that does for me, number 1, is it tells me 0 isn't a solution. Now when I go look at some of these other points, okay, so -2, 2 is on the line, and there's an equal sign. So this one is going to be a solution because it's on the line, and the inequality includes an equal to. When we look at 4, +4, -2, this is out of the boundary. It's not within the shaded region, so that one's not going to be a solution. And when we go to -4, 4, so here's -4, -4 would be here, and that's smack dab in the middle of the boundary, so that's going to be a solution. Again, you could plug all of these into this equation as well, or this inequality as well, and you just need the left to be less than or equal to the right is another way to do that, okay? Part C then asked us to shade the solutions. So we already did that in the way that I did it. And then are the points on the line included in the region? And yes, and I talked about that here. Yes, okay, because it's less than or equal to. So less than or equal. Okay, and that's because of this line right here means equal to, which means that the boundary line is part of the solution.